This is our last class of this subject. Okay, this is the last class. Okay, today we will finish this last topic. Okay, finite difference method for the hyperbolic equation. Okay, so some of you still haven't watched the recorded video of the finite difference method for the parabolic equation. Okay, so I hope those who haven't do so, you will have to watch the recorded video. Okay, for the class before this, okay, the one for the heat equation. Today we will look at wave equation. Okay, so this one that day I have already introduced, where we can solve the second order linear PDE using these two different methods, okay, analytical methods and numerical methods. Okay, so that look at this parabolic. So today we will look at this hyperbolic equation. Okay, so these are the formula. Formula will be given in the appendix in your final exam. Okay, so you have to know how to choose the correct formula. Okay, but if you look at this forward and backward, they give only the first order. Okay, the second order, they comes from central difference formula. Okay, you have to know that for the wave equation, both UTT and UXX are in second order. Okay, so we will take these two. Okay, for the wave equation. Okay, this is the wave equation. Okay, this is UTT, this is UXX. So for sure, we will get the formula from these two. Okay, so this is the model. Okay, we have boundary condition, we have initial condition, and we have the initial velocity. Okay, so by using the central difference formula, we will get this. Meaning that this one, UTT, you take the formula of this UTT. Okay, this is the one equals to C squared UXX. Okay, you take the UXX, this formula. Okay, you can choose to preserve the C squared UXX on the right. Okay, you don't have to move it to the left. Okay, and still we have the H and K as the step size for the X and T respectively. Okay, now we look at the first example. Approximate the solution for this wave equation. There's no aircon in this room as well, but the projector is much better than the BK6. Okay, approximate the solution for this wave equation with the boundary conditions given this initial condition and initial velocity. So from here, we know that our x from 0 up to 1 with a step size of 0.5. Okay, so 0, 0.5, 1. We have 3 points for the x. And for the t, we have 0 up to 1 with a step size of 1/3. So 0, 1/3, 2/3, and then 1. We have 4 different values for the t. Okay, so the first step will be we sketch for the grid points. Okay, so this now your x 0 up to 1 with a step size of 0.5, and your t from 0 to 1 with a step size of 1/3. Okay, so after you sketch for these grid points, okay, label the indexes of I and j. Okay, this one will be used for the labeling of internal points later. Okay, so after you sketch for the grid points, we will compute for the boundary and initial values. So this is the initial value, initial condition. Okay, initial condition. So your x, you have 3 values for x: 0, 0.5, and 1. Okay, this 0, that means no matter what is your x, your t remains. Okay, t remains 0. And to get the right hand side values, let's say this one, you just substitute your x into this x to get the right hand side values. For example, this one, x is 0. So that means this is 0. Sine 0 is 3. when x is 0.5, okay, this is 1/2. When this x is 1/2, cancel out the 2, you have pi. Sine pi is also 0. Okay, so when x is 1, sine 2 pi is still 0. Okay, that's why we get all 0 for the initial values. Okay, and for the boundary conditions, okay, p, we have 4 different values. Okay, 0 up to 1, okay, with a step size of 1/3. Okay, this is 4 values. Okay, but no matter what is your t value, your right hand side value remain all zeros. Okay, all zeros. Then you substitute all these points, okay, into the grid that you drawn just now. Okay, so this is for the initial condition 0, 0. That means this is the point 0, 0, which is 0, and 0.5, 0, 0.5 and 0. So this is also 0, and the third one is also 0, and this is for boundary. Okay, boundary. Okay, so you just match. Sorry, you just match the point. This is something like uxy. Okay, x and y. After you substitute all the boundary and initial values, you label the internal points. Okay, label the internal points. But this labeling, we do not use the xt, we use ij. Okay, we use ij. So for this point, you have 1, 1. That's why the label for this is u1, 1. Okay, this one, this is 1, 2. So that's why this is u1, 2. And u1, 3. Okay, this is how we label the internal points by using the axis. Okay, so there are 2 representations for the u. One is uxt. Okay, one is uxt. This one uxt. And another one is uij. Okay, basically, for example, this one, this is u11, and this can also be u bracket 0.5, comma 1/3, close the bracket. Okay, we have 2 ways to present the points. One is uxt, another one is uij. But for the internal points, we will use the uij because the formula given is in a ij form. Okay, and next, this is your PDE. Okay, this is your PDE. Both are in second order. So we will choose these 2 formulas. Okay, from the central difference formula, only these 2 are in second order. The rest, they are in first order. Okay, so we use these 2. You substitute these 2 into your PDE. Okay, so this one, basically, you can leave it on the right. Okay, you can leave this on the right. You don't have to move it to the left. Okay, after you substitute your upt and uxx by using the 2 formula just now, okay, then you get this. Okay, then we have 1, 2, 3, 4, 5 different u's. Okay, different from the heat equation. Heat equation, we have 4 different u, right? 4 different u's. But in wave equation, we have 5 different u's. So if you sketch on the grid points, see the I plus 1, I minus 1, and j plus 1, and j minus 1. If you plot all this u on the grid, you will see this is their location. Okay, this is their location. So similar to the heat equation, when you form this formula, we will tend to find one of the u to grid for the formula. Okay. So, okay, this one. Since we have the first row, the values of the first row, so we can find the points 1 row above. So we tend to choose this to lead for the formula. Okay, uij plus 1. This is the one. Okay, so we will choose uij plus 1. This one, uij plus 1 to stay on the left. That means the rest, we move them to the right. Okay, so this one, okay, we move this back to the right, and k squared, we move to the right. That means we have 4k squared over h squared. Multiplies to this one from here. Okay, that means we just simplify And then we move these two to the right. Then we get this 2. This is minus, plus, then we have plus minus. Okay, so now we have uij plus 1 to lead for your formula. Okay, and here, after you substitute your k and h, you get this 16 over 9. Okay, 16 over 9. So you expand. So 16 over 9 multiplies to this one, and this one. And then we combine the 1 for uij. Okay, we combine the 1 for uij. Okay, so if you look at the sequence, we would tend to choose this one as the first one, the second one, the third one, and this one as the last one. So you arrange your u in such a sequence. First, second, third, and last. Okay, so ui minus 1j first, followed by uij, followed by ui plus 1j. Then the last one is uij minus j minus 1. So let it follow this sequence. Later, you will find that your combination of the values will be very simple. Okay, because you know what is the sequence of the points. Okay, up to this point, any questions? Okay, next, we have one more condition, the initial condition, which is the initial velocity. Okay, initial velocity. Because according to this one, okay, this one we have these 3 points and 1 point underneath. If you look at your grid, okay, if we want to find for this, 1, 2, 3, and 1 more point underneath here, but we do not have the information for that point. That's why you are given the initial velocity for that point. Okay, this is the given initial velocity. Okay, so we discretize this one first. That means we put an I here, and this means del u del j. Okay, del u del j, where your j equals to 0. Okay, why j is equals to 0? Because we want the this one is uxt. Okay, uxt. Okay, uxt. So the one that give this one should be t. When t equals to 0, that means this is the row. Okay, t equals to 0. That means it refers. And this row, if we convert to the indexes of ij, that means the j is equals to 0. Okay, that means index j equals to 0, referring to this line where t equals to 0. Okay, that's why this one. Your t is 0 is referring to your index of j is equals to 0. Okay, then it is given by the initial velocity as 4. Okay, so this one we will use, since from the question that by central difference formula, so we will use the formula. Okay, we will take the formula from the central difference, the group of central difference. This is ut. Okay, this is ut. So if you look at this formula, under central difference formula, the ut is, okay, this is the formula. Okay, so you take that formula, this one. So this one, it is equals to 4. Okay, this one is equals to 4. Okay, this equals to 4, where you substitute your k is 1/3, and your j is equals to 0. Okay, this one, given that j equals to 0, means that this j, you will substitute j by 0. So you have ui1 minus ui negative 1. Okay, so in short, okay, I repeat once again, for the initial velocity, we take the formula from here. Okay, this is the formula that we are going to use for the initial velocity. And this one, this is equals to 4. Okay, equals to 4. But our initial velocity, j equals to 0. That's why you need to substitute this j and this j by 0, and the k is 1/3. And then it is equals to 4. Okay? Then you get this equation. So this one, 2/3, you move it to the right. So 4 times 2/3, you get 8/3. Okay, on the left, you have this one. Okay, and in between these two, we will let this ui minus 1 to split the formula. Ui minus 1. What does this mean? If you look at this one, I, and then j is -1. J is -1. This is what we want. Ui j minus 1, where when j is 0, you have ui -1. Okay, when j is 0. So we want the ui -1 to find for the point under the 3 points. We will use this formula. We will use this formula to find for the last point underneath that 3 points. Okay, so we let this lead the formula. Okay, so now you have 2 formulas. One for the overall, okay, one for overall, and this one specifically for this. Okay, but this one, it's happened for the first iteration. Okay, that means when you find for the u11, you do not have the point underneath, so that's why you need this formula. Okay, if you look at this one, you want to find for u11, so this is the formula, and we know that this, the first, second, third points referring to 0, 0, 0, all zeros. And then minus, okay, this one, u11, if you compare this to your u11, that means your I is 1. Okay, I is 1. J plus 1 equals to 1, that means j is 0. So I is 1, j is 0. When you substitute all I and j by using these 2 values, this is u1, comma, -1. Because j is 0. Okay, j is 0. So u1, -1, this one. u1. So to get u1, -1, we have to make use of the second formula. Okay, so this one, second formula, you compare this one to this, this means I is 1. I is 1. So you just substitute I equals to 1 into this. This means it is equals to u11 minus 8/3. So you substitute this one by u11 minus 8/3. Okay. And this u11, we know that u11 is the same as this one, right? So when you open this bracket, bring this minus u11 to the left. That means you have a plus. u11 plus u11, you get 2 u11. And for the rest of the values, you just combine. And finally, you can get your u11. But this is just applying for the first iteration, because for the second iteration, when you get this value, and next you will find for this. Okay, so at this moment, you have this 1, 2, 3, and this. That means from the second iteration onwards, you do not need to use the second formula just now. This is used only for the first iteration, because your first iteration, when you want to find for this, you do not have the last point underneath. That's why you need to use this second formula. But after that, when you get to find this, and next you want to find for u12, the 4 points will be 1, 2, 3, 4. You just substitute the points directly. Okay, this one. The first point, the second point, the third, and the last. So you minus 0, last one. Then you will get your u12. Okay, once you obtain your u12, update into your grid and find for the next u13. So when you want to find for u13, this 1, 2, 3, 4, 4 u's referring to 1, 2, 3, 4. So you just substitute them directly into the formula, then you will get u13. Okay, so only the first iteration, you need the second formula. Okay, then this is the final solution. Okay, so compared to the heat equation is simpler, okay, because it doesn't have the initial velocity where you need to find for the last point underneath. Okay. But the working is similar. The working is similar. Okay, just that this has an extra steps. Okay, any questions for this first example? Okay, now we look at the second example. Okay, you are given this PDE, boundary conditions, initial conditions, and initial velocity. Okay, h is 1/3, k is 0.5. Both x and t are from 0 up to 1. Okay, so 0 up to 1 with a step size of 1/3. So that's why you have 4 points for x now. And t 0 up to 1 with a step size of 0.5. So you have 3 points for the t. Okay, then label your ij indexes. Then find for the boundary and initial values. Okay, this working is same as the heat equation. Okay. So whenever you see x, this one, when you see a variable, this means you have to put in all the values from the grid. Okay, this t is also a variable, so all values from the grid. If you see just a constant, that means all will be constant. Okay, so this is not necessary to be always 0. It can be any other values. Let's say this is 2. Okay, let's say this is 2. Then this will be 2, 2, 2. Okay, when it is constant, it will remain constant. Okay, unless you see a variable t, that means you have to use the all the values from the grid. Your t, you have 3 values, okay? 0, 0.5, and 1. That's why you have this 0, 0.5, and 1. Okay, but if it is constant, it will remain constant always. Okay, then next, substitute all these points into the grid. Okay, into the grid. Then you get all this. Okay, so from here, actually, we can see that the boundary and initial conditions are symmetrical about the line x equals to 0.5. X equals to 0.5, that's mean here. Okay. If you have a line here, you see this point is the same with this. This point is the same with this. This one same with this, and this one same with this. That means all these boundary and initial values are symmetrical about the x equals to 0.5. So when you see these conditions, meaning that the internal points is always it will be the same. This one will be the same with this. This one will be the same with this. Okay. So we do not need to find 4 points. We just need to find these 2. Because once you get this, you put the same value here. And after that, when you find this, you put the same value here. Okay, this is symmetrical. But if you want to try to find all 4 points, you will find that they have the same values. Okay, these 2 have the same values. Okay. Next, we will form the formula. Okay, formula is set to the same. Both are in second order, so we take the formula from the list. Okay, then this one, suppose this one you can remain it on the right hand side. Then you just move the k squared to the right. Okay, k squared to the right, so you have k squared over this h squared. Okay, multiply with this in the bracket. Okay, then these 2 move to the right. We want only this uij plus 1 to stay on the left. Okay, then substitute your k and h, and when you simplify, you get 2.25. Okay, 2.25, you multiply into all these 3, then you combine the uij. Okay, combine the uij, then you arrange the u, these 4 different u's in this sequence. This is the first, this is the second, third, and fourth. And after that, you have to find for the second formula from the initial velocity. Okay, this is the given initial velocity. Okay, since this t is 0, that means your j equals to 0, referring to the line of t equals to 0. Okay. So we will take the formula. This is the formula to be used. Since your j equals to 0, we substitute j by 0, j by 0. So you have ui1 minus ui negative 1. Okay, k is 0.5. Okay, this is equals to 1. That's why here this is 1. So you simplify this one. we want the ui negative 1 to lead the formula. Okay, ui negative 1, the one with negative 1 to lead for the formula. Okay, once you have get these two formulas, okay, you can start to find for this u11. Okay, but because of the symmetrical, you can write down this line because of the symmetrical. Hence, this u21 equals to u11, u22 equals to u12. Then you find only for these 2 points. Okay, so first we will find for this u11. So u11, we do not have the 4th point underneath, so we have to use this formula. Okay, so for the first one, you can substitute. Okay, you can substitute the I and j. Okay, you can compare this u11 to this uij plus 1. That means I is 1, j plus 1 equals to 1. That means j equals to 0. So I is 1, j is 0. When you substitute I and j values, you get this line. You get this line. Then 1, 2, 3, referring to this 1, 2, 3 value. Okay, we are finding for this. So the 3 points underneath, the first 3 points. And the last one, this ui negative 1, we will use this formula. Okay, ui negative 1 means that your I is 1. So when I is 1, you have u11 minus 1. Okay, this is u11 minus 1. Keep a bracket because of the minus here. Okay, then this minus u11 move it to the left. So you have 2 u11. And for the right hand side, all constants, you just find using your calculator. Then finally, you get your u11. Okay, so this is your u11, meaning that your u21 has the same value. Okay, so you just fill up your grid with the values found just now. Okay, then next we find for u12. Okay, u12, we are using this formula. One formula is enough. So this first, second, third, fourth u, it comes from 1, 2, 3, 4. Okay, you just substitute the 4 points into the formula, then you get your u12 directly. Okay, so this value is the same with this u22. Okay, these 2 values are the same. So this is the final solution. Okay. Okay, now let's try this exercise. Okay, try this. Okay, sketch the grid first. X 0 up to 1 with a step size of 0.25. Okay, T from 0 up to 0.1 with a step size of 0.05. Let's say you have two values. Okay. Then label your ij indexes. And you can also label your internal points. But before that, before that, we can find for the boundary initial values first. Find x. So you have 1, 2, 3, 4, 5. 5 different values of x. So when you see a sine function, a triple function, it's radian because you don't see any degree, okay, degree symbol. That's why you have to use radian. Okay, unless here this is 0.25 degree, then you use degree. This may not be zero always. Okay, may not be zero always. This one can be other constants, can be the one with variables. Okay. So this one, when x is 0, sine 0 is 0. This one, 0 as well. 0. This one, this is 1 over 2. Pi over 2, sine pi over 2 is 1, right? Here, the 0 is 1. This is 1. Pi of this is 0.7071. Yes. Then this one. 7071. Sine pi is 0. Okay. And this one, t is 0. This one equals to 0. Okay, when you have 3 different values for t, find 0, 0.1. All will be 0. Okay, and this may not be always 0. If this is, let's say you are given 3. Okay, if this is equals to 3, that means all will be 3. Okay, if this is given as 2t, okay, if this one, if this is equals to 2t, that means t is 0, you get 0. T is this one, you get 0.01. This one times 2, 0.2. Okay, for finite difference method, this can be anything. Okay, for the boundary. For the boundary. And the second boundary condition on 1t. This is also the same. Okay. Then you substitute all the points into the equation. Okay. Then label the internal points. The internal points. This is 1, 1. This is 2, 1. 3, 1. Okay. This is 1, 2. This is 2, 2. Then 3, 2. Okay, actually from the initial values, you can see that this boundary conditions and initial conditions, they are symmetrical above the line x equals to 0.5. Okay, 0.5. So that's why if the U31 will be equals to U11, U32 will be equals to U12. So you just need to find for the 4 points. Okay, instead of 6 points, you just need to find for this 4 points. Okay, because of the symmetrical. The boundary and initial condition are symmetrical above the line x equals to 0.5. Okay. And U31 equals to U11. U32 equals to U12. Discretize your PDE, then find for the formulas from the list, okay, from the central difference formula. Okay. So we use these two formulas. Here. J plus 1 minus 2 uij plus uij minus 1 is squared. It equals to ui plus 1 j minus 2 uij plus ui minus 1 j over h squared. And we know that we want the uij plus 1 to leave. So we move the k to the right. That's mean k squared over h squared. And move this to the right. And at the same time, you can substitute the h and k. Zero point zero five. Well, h is 0.25 squared. Okay, minus 2, well, you get a plus 2, you will find 3. And then minus you find j 1. Okay, then you have to decide the sequence of the u in the formula. Okay, this one, the one with minus 1, okay, on the j, this is the last point. Okay, this is the last point. And ui minus 1 first. Ui minus 1 first, this is the first point. Uij, the second one, and then the last one is ui plus 1. Okay, and not the last one, the third one. Okay, the first I minus 1, and then I plus 1, and then the last one is the one j with negative values. Okay, but of course you have to combine this one with this u first. Okay, after you open the bracket. So what do you get? 0.04. 0.04. Okay, so 0.04, that means this one first. Ui minus 1 j, and then 0.04 times negative 2, and then plus 2. What is the value? 1 times negative 2, okay, and then you plus 2. .922. Okay, this is for uij. And then the third one, 0.04 ui plus 1 j. Then the last one, minus uij minus 1. Okay, so this is your formula. This is your first formula. The second formula, find from the initial velocity. Okay, your initial velocity is 0. Del u del t. Del t x 0. This one we can write in the form of del u del t and I comma j equals to 0. So t equals to 0. T equals to 0, it represents this x-axis. Okay, t equals to 0. Okay, for this x-axis under ij index, j equals to 0. That's why your j is 0. Okay, and this one you have to find from the formula. Okay, this one central difference formula. Okay, from the central difference formula. Okay, just now this is equals to 0. So this one, uij plus 1, ui del u del t j equals to u times j plus 1. J plus 1 minus u times j minus 1 to k. Okay. So this is for del u del t I j. But what we want is this one. Del u del t I, but j equals to 0. Okay, what we want is j equals to 0. This one equals to 0. This one also equals to 0. ui1 minus ui negative 1. Okay, substitute your k 0.05. But this is equal to your initial velocity equals to 0. So from here, get your second formula. That what means here. Your ui1 minus ui negative 1 equals to this one, move up 0. But we want the ui negative 1 to lead the formula. So this one goes to the right, this means equals to ui1. Then now you have two formulas. Two formulas. Okay, now we start from u11. Okay, we find for the u11. U11. 0.04. Okay. Your first point, or for the first iteration, find for the ij. U11 compared to this one, I is 1. J is 0. Okay, J is 0 because 1 equals to J plus 1. This means J is 0. I is 1, J is 0. So you have U11. 0.04 U, when you substitute this 1 and 0, 1 minus 1, 0. J, 0. IJ, 1, 0. I is 1. So you have 2, 0. I is 1, J is 0, that means minus 1. Okay. This, right, you know what are the points? Get this one. These are the 3 values. 0, minus U1 negative 1. Okay, you have to find the U1 negative 1. That means I is 1. Okay, I is 1. When I is 1, this I is 1. So that means this is equals to U11. This one equals to U11. Okay. So again, this one equals to this. When you equal this to, you find that I is 1. Okay, I is 1. When I is 1, that means this is 1. U11. This is equals to U11. So this U11, we will move this to the left to combine with this U11. So you have 2 U11. Then find 6 value. So what do you get for this one? 0.661. 9. 0. 6190. 6109. 9. 69. 05. So your U11 will be 0.. Okay. U11 is 1.3976. Okay, divided by 2. Wait, 988. Any questions for this one? You want one? Once you get this, push back to the grade 6, 9, 8, 8. Okay, that means your U31 is also the same. Next, we find for U21. Okay, U21. Okay, this follow this 0.04. Okay, U21. U21. Okay, to get the U21, we also need to find for the last point underneath. It's not provided, but you have to get from this second formula. So this one is you know this. Okay, the last one it will be because your I is 2. Okay, I is 2, so you have U21. Okay. So if you are not sure, you can compare this one to the formula. Okay. Uij plus 1. So I is 2, j is 1. And j is 0, sorry. I is 2, j is 0. So U01, U01 plus 1.92, U20. U30. 10, it's 1. 10, 20, 30. Then minus the U. Just now it's Uij minus 1. So I is 2 now. U2. J is 0, 0 minus 1. So negative 1. Okay, this is the first. Okay, if you use this one, this is the first line that you get. J Uij minus 1. Okay, then substitute the 3 points first. Your U2 negative 1 is also U21. So combine. Okay, so what is the value before divided by 2? And you will take it. So your U21 will be 1.9766. Okay, divided by 2. 9883. Okay. Then find for U21. Okay, U21 is equal. Because you have got the 4th point in the grid. You do not need to use the second formula to get the value. Okay, you want to, or you want to? You want to, this one. Okay, everyone sign for your attendance. Zero, 1, 0, 4. Find it. 1, 2, 3, 4. Then minus the you want to. You want to is 0.6741. That correct? Oh, 698. 9. U32 will be the same. And the last one, U22. Okay, U22, that's name. 1, 2, 3, 4. Two, 0.9534. Okay, any questions? No. Okay, next we try number 2. Okay, sketch the grid first. X0 up to 5. 8 is 5/4. 8 is 0.5. Okay, so that means your X, you have 5 values. A, you have 2 values similar to the question this one. Okay, so x is 0. When x is 0, you get 0. When x is pi over 4, you get a value 0.7256. Pi over 2, 1 point. 1 point. 1107. Next one. One seven. When x is pi, 0. Okay. No symmetrical. This means I can find all the values. Five zero, 5, all 0. Fill up the values. Then label the infinite points. 1, 1, 2, 1, 3, 1. 1, 2. 2, 2, 3, 2. Okay. Then you can start to form your formula, the first formula. So you have this one. 9 del square u del x. Okay, so we use these two formulas. Okay. 9. Keep the uij plus 1 on the left. Okay, substitute the K and H and move this two to the right. Okay, so what is the value for this? You get a value? 6, 4, 6. Okay. Then you have to identify this is the first point, I minus 1 first, and then I plus 1. And this is the last one. So the big one times ui minus 1 first. Then this value times -2 plus 2. What do you get? This one times -2 plus 2. Minus. Five point two nine 5 2. Okay. And then the third one. And the last one. And the second The second formula, value del t x0 is not equals to 2. Okay, equals to 2. Equals to 2. This is value del t ij equals to 0 equals to 2. Okay, so define for the original one first, value del t for ij is this one, uij plus 1. And this uij minus 1 over 2k. Okay, so our case is j equals to 0. So when j is 0, you have ui1 minus ui 0 minus 1 to get -1. Your k is 0.5. So simplify. You have ui1 minus ui -1 equals to 2. Okay, so this one, we want this ui -1 to split. Okay, so we want this one to split. And ui -1 equals to ui1 minus 2. So this is the first formula. This is the second formula. Any questions? Have you done this one? Then you start to find for the u11. Okay, u11. This is u00, u10, u20. then minus, okay, I is 1. Okay, I is 1. This one, you compare this one. I is 1, J is 0. Okay, J is 0. So when J is 0, you have -1. Okay, I is 1, J is 0. So 1, -1. Then substitute the points. U 0, 0 is 0. U1 0, 0.725. U2 0 is 1.1107 minus U1 -1. U1 -1 means U1 1. Okay, I is 1. So U1 1 minus 2. Okay, so what is your U2 U1 1? Point 20. 2.209 2. Zero 90. That's 0.2092. So your U1 1 is U1 1. Have you plus 2? No. So 1.1046. Okay. Next one, U2 1. U2 1. U2 1. U2 1 means I is 2. J is still 0. Okay, I is 2, J is still 0. Two, two, one. So that means this 1, 2, 3. This is 1, 0. 1, 0, 2, 0, 3, 0. Minus. Okay, I is 2 now. I is 2, so you 2, negative 1. Negative 1. You 2, negative 1. U 2, negative 1. 2, negative 1 means U 2, 1 minus 2. If I do 2, U 2, 1. 2.05, 4, 2.0272. Next is U 3, 1. U 3, 1. So you have U 2, 0, 3, 0, 1, 0. Okay, U 3, 1. We compare this one, I is 3, J is 0. Okay, I is 3, J is 0. So meaning that here you have I is 3. This one is negative 1. 3, negative 1. U 3, negative 1. That means U 1 minus 2. Basically, the steps is still repeating. Okay, what is the U3 one? 1.027. 1.27. 6.7. Yeah, this is 8. This is 3.1. 0.6384. Okay, so after the row, we just take the value directly. 1, 2, 3, 4. Okay. You want to row and minus the one underneath, and you can get the value back. U12 is negative 2.8279. Into 2. Okay, just put in the 4 values directly. If you have put your formula in order, U22 0.1046. Next one is 1107. U32 negative 0.1922. Last one, U32. U32. Questions? No. Very simple, right? This one, I would say, this topic is the simplest among the rest. If you just need to follow, if you are given the formula, you just need to follow the steps. Okay, I think that day I have discussed about, I have shown the past year questions in the video of the last class. Okay, so you can start to try. Okay, start to try because your final exam is on 1st of July. In 1st of July, afternoon to 15 at the one chancellor. Okay. So I think I will have one more revision class with you before your final exam. But to update the date and time in the group. Okay. So please try first. Okay, try first for the final exam question, past year final exam questions. Okay. So we keep in touch in the group.